Okay, this is notes 2.3.4 for January 31st. We have covered some of this earlier, but I'm going to review it. Quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So we're going to be using this on these problems. So starting with problem 1, my a is 1, my b is negative 2, and my c is negative 2. So solving, we say that the trig function sine theta equals 2, because that's negative b, plus or minus the square root of b squared, which is 4, minus 4, times 1 times negative 2, all over 2 times 1. So that will be 2 plus or minus the square root of 4 plus 8 over 2. That equals 2 plus or minus the square root of 12 over 2. This is sine theta. Now, since we are going to be finding theta, there is really no need to simplify this expression. So theta equals sine inverse of 2 plus or minus the square root of 12 over 2. So I need to pull out my calculator. We need to do these one at a time. So theta equals sine inverse of 2 plus the square root of 12 over 2. Now you can use Desmos, scientific calculator. And I need to flip back. Okay, so that's 2 plus the square root of 12 over 2. We're going to do sine inverse of 2 plus square root of 12 divided by 2. And notice it says undefined. It says undefined because 2 plus the square root of 12 over 2 is bigger than 1. And sine cannot be bigger than 1. So our second one was the same thing except minus the square root of 12. And we're going to do this in radian mode. So rounding it, I get negative 0.82. So theta equals negative 0.82 rounded to 2 decimal places. However, the directions say up here that it has to be between 0 and 2 pi. Well, this is negative, so it can't be. So we're going to add 2 pi to it. Okay, so I'm going to go back to Desmos. And I'm going to say 2 pi plus, and I get 5.46. Now, I know that negative 0.82 and 5.46 are both fourth quadrant angles. So that means that my sine value had to be negative. So what we actually found here, sorry, I want to fix this, is sine inverse of 2 minus square root of 12 all over 2, because this was undefined. Okay, so 5.46 and negative 0.82 are coterminal angles. Now I know that negative 0.82 is here. All students take calculus. I also know that the other place where sine is negative is here. I know that this angle is 0.82. So to get the other angle, I have to add pi to 0.82. So my other theta is pi plus 0.82, which is approximately 3.14 plus 0.82, which gives me 3.96. So these are my two answers for this equation. Okay. Moving on to the second problem. My A is 1, my B is 3, and my C is 1. So plugging it into the quadratic formula, but this time my trig function is tan x equals negative 3 plus or minus the square root of 9 minus 4 times 1 all over 2 times 1. Okay, so I'm going to get for this one negative 3 plus or minus the square root of 5 all over 2. So I'm going to get two answers. I have tan x equals negative 3 plus the square root of 5 over 2, and tan x equals negative 3 minus the square root of 5 over 2. So I need to take the tan inverse. So let's see what we get. Okay, I get negative 0.36. So let's go back here. Okay, we ran into the same problem that we did before. So we have to find the coterminal angle. Okay, so I'm going to go back to Desmos and I'm going to add 2 pi. And I get 5.92. Okay, that's one of my solutions. Now with tangent, I know that this, once again, is a fourth quadrant angle. This is 0.36. Now, the other place that tangent is negative is here. So if I take pi, and I add negative 0.36, I'm going to get the second angle. Okay, so 8. $2.78. Okay, that's from my first one. Now I need to do my second one. So let's go back to Desmos. And it looks like I'm going to take this off temporarily. Oh, won't let me do that. Okay, so I got another negative number. So I have to put the 2 pi back. And I get 5.07, 5.08. Oh, I'm going to add the 2 pi here. And once again, just like I did here, instead of adding 2 pi, the second time I'm going to add pi, and that will give me my other angle. Okay, so let's go back to Desmos. And I'm going to take the 2 off. And this time I get 1.94. Okay, so I have my 2 answers. So this problem has 4 answers altogether. Okay, so that's using the quadratic formula. Last problem. Using inverse functions. Okay, so the first thing I'm going to do is see if this is factorable. So set this up. 3 times 2 is 6, and negative 7. Well, negative 6 times negative 1 is positive 6. I add them together, I get negative 7. But I have a leading coefficient of 3, so whoops. Let's try that again. Okay. So it's definitely factorable. I get cosine x minus 2 times cosine x, oopsies, forgot about the 3, minus 1. Okay, and that's going to equal 0. All right. So I have cosine x minus 2 equals 0. And I have 3 cosine x minus 1 equals 0. So cosine x, if I add 2 to both sides, equals 2. And guess what? This is not between negative 1 and 1. So right here, no solution, or undefined, however you want to state it. Okay, so I get 3 cosine x equals 1. Cosine x equals a third. X equals cosine inverse of 1/3. Okay, it says to use inverse functions. Well, this is an inverse function. However, back to our diagram again. Okay, this is positive. So I know that my other angle, this one's going to be here. My other angle is going to be there. So this, since this is positive, this value is my reference angle. So what I have to do to get my other angle is going to be x equals 2 pi minus my inverse function. And that's how we use inverse functions, to find all the solutions. I hope this was helpful and you can get started on your assignment.